Hi everyone and welcome to this Git series. In this series we will learn Git step by step. So let's begin. So what is the Git? So Git is basically a free open source distributed version control system. It is abbreviated as DVCS. So distributed version control system, and this system was developed by Linus in 2005. Now here are two keywords which we need to understand. One is distributed and one is version control system. So first let's understand about version control system. What is control system and how it is beneficial when you are working as a developer or the automation test engineer. Okay, so when we talk about version control systems, so they are basically softwares which tracks the changes to the files over the time, and it allows you to recall the specific versions later. So basically, this is a system or software which track the changes over the time. Track changes over the time. And when we talk about over time, so basically it allows to recall specific versions. Now, what are these specific versions? So when we talk about versions over here, so let's suppose you have start writing a code, and today you have automated login, or you have developed the login feature. Now today you have completed this work, and this is known as the first copy or the version 1. Now tomorrow you come and you start adding more things. You have added for sign up, and now the code has both login plus sign up. Now this copy of the code is known as version 2. Similarly, any kind of a changes makes a copy of your code, and that is known as version. Now these version control system basically help to the history track history. Now when we talk about tracking history, what it will do is that it will record every change. Record every change. Now assume that you are manually doing it. You are creating the different copy of your files. Now it is really hard to maintain and track the changes. Who made those changes, why those changes were made, when those changes were made. So you are actually creating the different copies and managing it manually. But those version control systems basically help to record every change, and you can exactly see what, when, and why there was a change in code. Okay, and secondly, when you're working with writing the code, what happens is that sometimes you made a mistake as a developer or as an automation engineer. You made a mistake. Then what you do? So basically, you can instantly undo the changes, and you can go to the previous copy or the version of the software. Now, third thing is that it helps in the collaboration. So basically, multiple people can work on the same project simultaneously without overwriting each other code. So basically, this collaboration allows people to work on same project simul- simultaneously without overwriting each other. if we don't have these version control systems, so what happens that the other developer or the other automation engineer might override your changes. And again, it might break your code. So that's why we need a version control system. Now let's take another real life example. For example, the Google Docs, right? And you're adding different stuff on daily basis. So it keeps the version history, but it's not that powerful when we are talking about the managing the code and different versions. Now, you hopefully you understand that what this version control systems do, right? Now here, let's talk about what are the centralized or distributed version control system. So basically, when we talk about the you know version system controls, so basically there are two types. One is centralized, one is centralized, and other is distributed. Now, when we talk about centralized, what it means. So, centralized basically uses a single central server. So, previously there was a tool called SVN. So, SVN was basically a centralized single server which contains the version files. So, different versions of files are available on a centralized version. So clients connect to that server. So we usually, as a developer or automation engineer, we connect to that server and check out the files and make the change. Now it has some pros and cons. So when we talk about the advantages, it was easy to understand because there was only one master copy of your code. So everyone is looking into that one, and the administrators have a fine grained control over who can do what. So there is control. But the problem here is that the single point of failure. So if server goes down, server goes down, or anything happens with the server, internet connectivity. So what happens is that nobody, nobody can save changes. So this means that you cannot collaborate if this thing something happened with that particular server. Now, in contrast, when we talk about the distributed, so distributed is basically works in a different way. Okay, so when we talk about the distributed one, so what we do is that we don't just check out the latest snapshot, they fully mirror the repo. So repo means where you have the code repository. So each clone complete backup of the entire project. Now, when we are talking about distributed ones, so Git is basically a distributed version control system. So what happens is that when you're using the Git, so you can work offline. So you can commit, make the branches without the internet connection. Then every clone is a full backup. So if server dies, anyone can restore it. Okay. Then again, speed, because most operations are local. You're doing the changes locally, but you will not be dependent on the server every time, right? So this is how the distributed version control system works. And Git is basically a distributed version control system. So now we have developed and very good understanding. So Git is basically the open source distributed version control system. And when we talk about version control system, they are basically help to track the different versions or to control the different versions. They help us to track the history, help us in the collaborations. We can track every change. We can do the instant undo changes. We can allow people to work on the same project simultaneously without overwriting each other's codes. So if we try to do it manually, so for example, you are changing manually, you're giving the files to the other developer using the email or through the portable drives. One is making changes. So there's likely that it will create more effort, and it will actually very hard to track who made those changes which are causing the break in the software or in the automation scripts. So in order to manage these things, so basically we use the version control system. And as Git is distributed one, so distributed basically just don't check out the latest copy or the snapshot. They fully mirror the repository, and you can work offline. Every developer or the automation engineer has their own full copy. Okay, so they are less dependent on the internet. They can make the changes and they can collaborate easily, so you can easily track those changes, who made what, when, and why through the commits. So this is a basic introduction about the Git. In our upcoming sessions, we will start downloading, installing, and keep learning step by step. Hey everyone, welcome back to the channel. If you're just getting started with the version control or you have been putting off setting up the Git on your Windows machine, today is the day we will fix that. In this tutorial, I will walk you through downloading, installing, and configuring the Git on your Windows from the scratch. It's super simple, so let's begin. The first thing you need to do is that you need to go to the browser, and the browser you need to search for download Git, and this is the official website git-scm.com. Always download Git from the official website, never use random third-party sources. Now click on this one over here. If you're using the Windows, just click on Windows. If you're using Mac OS or Linux, just click respectively. I'm using the Windows right now. Let me click over here. Click here to download, and it will start downloading the Git. Now once the file has been downloaded, what we need to do is that we just need to double click on this one. You will get a user control pop-up, and here you need to press yes, and you will see a general public license. Simply click on next. This is the location where Git will be installed, and I would recommend that go with this default path right now. Just click next. But before that, you need to ensure that you should have at least 330 MB of free space. So if you don't have that space, you will having issues. So simply click on next. Now here you see that there's some different options like Windows Explorer, Git Bash here, Git UI. So again, go with the default options over here. And then in terms of setup the create program shortcuts, so click yes. And then here it asks for the editor. So you need to choose the default editor which needs to be used by the Git. So I would recommend again go with the Vim editor as a Git's default editor. You can change from here if you're using any other, but I would recommend to go with this one. Click next, and here basically what we need to do is that we need to decide the name of the initial branch in the new repositories. So the default usually this should be the branch name which you are using on your GitHub or any cloud platform. For example, if you're using GitLab or GitHub, any kind of a platform. So basically, it needs to be main. If you're using master, it should be master. So for example, if you're using a master on the GitHub, just click here and type master. Okay, and click next. But right now, let me go with the main and next. And here we have basically adjusting the path for the environment. Here basically what we need to do is that we need to select the recommended option, Git from the command line and also the third party software. This is a recommended option and we will be going with this particular option. Click next. Then we have choosing the sh executable. Again, go with the default selected option. Then again, go with the default selector option for the HTTP transport backend. Then configure the line ending conversation. Again, if you want, you can go with the checkout as is commit unique style. You can go with the checkout as is commit as is. So it's depending on what kind of style you want. So usually people prefer to go with this default option. So go with this one. Again, use the default option here, and again choose the default behavior of git pull. So basically what happens is that you need to take a pull. So when you're working as a team, you want to need a latest changes of the code from the GitHub or GitLab, and now you need to define the default behavior. So what is the default behavior here? So it can fast forward or merge, which is the recommended one, or you can rebase the current branch. Again, you can do the rebase moving forward when you're working with the Git. Right now, just go with the fast forward or merge option. Click next. Click next for the credentials. Enable the system caching. Install. Now it will basically install the Git on your Windows machine. So once this solution will be completed, what we will do is that we need to verify that Git is basically being installed properly on Windows machine or not. So once it will complete, what we will do is that simply remove this check, click finish, and go here, go to the command prompt, and let's verify. So simply type git dash dash version. And if you see the version over here, which we just downloaded and installed, this means that Git is working fine and it has been installed properly. Okay. Now, what we need to do is that we need to set up few things. Before using the Git, we need to configure our identity. Now, this information is basically attached with every change we do as a part of your commit, right? So simply what we need to do is that we can open any folder, we can create any folder. So if I right click on this one on the desktop, if I click on the show more options, you will see this Git UI here and Git bash over here. So before installation, you won't be able to see these options. Now simply let me create one new folder here, and I'll say Git tutorials, and right click on this folder, go to more options, and click Git bash over here. You can go with the UI here, but I would recommend you to use the commands. So simply Git bash over here. And once you have this thing, just let me increase the size, you will see something like this. And now we need to set our username and email. Okay. So basically what we need to do is that we need to use a command called git config. So git config dash dash global and user dot name. So if you're doing it for the first time, you need to provide the username. So your username and the email should be same which you used for the sign up on the GitHub or the GitLab, right? So what I do is that I simply press enter over here. So it says your name. So what I need to do is that simply I'll say my name is Sean.Asghar. And now in a similar way, I need to go with my, so let me remove this from here. So user dot email, and here I need to provide my email. So you need to provide the email through which you have signed up your GitHub account. Now press enter. Now I run these commands without providing the name. So it will provide the my username, and in a similar way, it will provide the email, right? So this is the email, and now we have done with this. Once you have done with this thing, so let's verify our configuration. So I will type git config dash dash list. So you will see that these are the things here, my name and email. So if you are using some other credentials, you can update this one anytime, right? Now what we need to do is that we can simply initiate the git. So whatever the folder you're using for the application, right now we are using this folder. So what I'll do is that I will simply initiate the git. So initialize a git repository basically. So in order to do that, otherwise git won't be able to track the changes which we will do later. So simple git init and press enter. Now this folder is basically being initialized as a git repository. Now git will track the changes over here. So this is basically a very basic installation and configuration. So basically what we did is that we just install the git, we configure, and we are ready to go to our machine. And now in the next video I'll show you how to connect the git to the GitHub and push your first project to the cloud. And so make sure you subscribe so you don't miss that. If this video helped you, drop a like, comment. It really helps my channel. If you have any questions, just leave them in the comments below. I'll get back to you. So see you in the next video. Hello everyone and welcome back to the channel. Have you ever wondered where exactly your code lives before you commit the code? Why Git needs something called a staging area? What is the difference between local repository and a remote repository? Most of the beginners, what they do is that they just memorize the commands, but they don't understand the Git stages. In this video, I will clearly explain what is the working directory, staging area, local repository, and the remote repository. And most importantly, why Git is designed this way. So let's begin. So the Git basically works in the four main stages. The first one is the working directory. The second one is the staging area. Third is the local repository. Then finally we have the remote repository. Now think of it as a flow of changes moving from step by step through the different stages. Now what we'll do is that let's understand each stage deeply. The first stage is basically a working directory. Now, this working directory is basically this is your project folder. Now, it contains the source files, test scripts, automation framework, feature file, configuration files. So, whenever you create a new file here in this stage, you can modify, delete, or make the changes here in this the working directory. Okay, so in simple words, this is the place where your development happens. Now, why we need this working stage over here? So basically, we need a space. We need a space where we can experiment, we can edit, we can test our code, we can write our code, we can modify our code without affecting the project history. Now, let's talk about the second area, which is the staging area. Now, this is the most understood, misunderstood part of the Git. Why? Because it is a temporary area which holds the files. So before moving forward, before committing something, you must select which files you want to save. Which files? So you might be working on 10 files, but you want to move or commit only 5 files where you are sure that this needs to move forward. So Git allows you to choose the specific files. So for example, from 10 files, you only move those 2 or 10 files. Okay. So basically the idea here is that if you are working on more than 5 or more files and you only showed about a couple of files, you only move those files. So this is a temporary holding area, right? Now, this stage allows selective commit. So in the real time scenario, if I talk about the automation testing, so what happens is that you are working on the login test, you are working on the payment test, you're writing the config file. Now, assume that the payment test is not complete. So you can only move the login test from here to here and the config file, not the payment test, because you are still working on the payment test, which is not complete. So we can review those files even later on the stage. If you think that you have committed something but you need to change, then you can easily move back to the working area, make the changes, and then move this one. Okay. Now, why this staging area is powerful? Because it gives the control. It prevents accidental commits. It allows the clean version history. It helps write meaningful commit. This is why Git is better than the older version control systems. Now let's talk about the third stage, which is a local repository. So you see that these three are the local ones over here. So when you run a command called git commit, so basically it saves a snapshot inside your system. That snapshot is stored in .git folder. Now this is called a local repository. So commit is equals to a permanent save point in your system, in your machine. Even if you delete the file, you break the file, you can recover from the commit history. You need to remember this thing. So why we need a local repository? Because it keeps the version history, it allows rollback, it enables branching, it tracks full change history. Everything is stored locally on your machine. So these three stages are basically referring to all things on your local machine. Okay. Now, where we have a fourth stage here. The fourth stage is basically this remote repo. Now, when you want to collaborate with other team members, so you need a remote repository like GitHub, GitLab, Bitbucket. So this is a cloud platforms where you have a repo, a shared content central server. So you are committing something. So it's still here, it's a local. Now, after from here, if you move something here, which we usually call as a push, so we are moving our local code which is committed to the remote repository. So remote repository always refer to the repositories which are hosted online like GitHub, GitLab, Bitbucket. Now your code moves from local repo to remote repo. So why remote repo? Because teams need to share the code. The team lead needs to review the code. We can collaborate, we can trigger the CI/CD pipelines. So without remote repository, team collaboration is impossible. Either you can give the code through the emails, through the USBs. That is not practically possible in most of the cases. So before I end this session, let me quickly summarize this one. So basically, this working directory is where we edit and write the code. This is the local on our machine. Then we have staging area. Again, this is a local one. And here we have an option to select the changes for the commit. So if we have 10 files and we want to commit only 5, so we can move only 5 over here. And then we have a local repository. Here, basically, we save the history permanently. Okay. And finally, we have this remote repositories. So basically, to share and collaborate, and this is hosted on some server online. Now, why Git is designed like this? So Git actually separates the stages because of the safety, control, history, and collaboration. So when we talk about the safety, nothing is committed automatically. So you are committing the code when you're sure about committing it, right? You have the safe zone here as well, right? You have a control. If you move from here, you can go back. So you choose what to commit and what not to commit locally. So every change you make, it creates a history. So every commit is tracked. Finally, collaboration remote makes teamwork really easy. So this architecture makes Git really powerful. Now you clearly understood the Git stages. Most people use Git daily, but very few truly understand how it works internally. In the next video, we will connect all these stages and see the full workflow in action. So if you found this helpful, subscribe for the complete Git for the QA series. Hi everyone, welcome to the channel. So most of the developers or the automation engineers use the Git every day, but they really don't understand the workflow. Now, what they do instead is that they just memorize the commands like git add, git commit, git push, but they exactly don't know what is happening between the different stages. So in this video, I will show you exactly how your code moves through the git stages. So let's begin. In our previous video, I have explained that there are four Git stages. One is working directory, one is staging area, then we have local repository, and finally we have the remote repository. Now, let's take an example. You are working on 10 different files, 5 are ready, and all of this work you are doing in your local or the working directory. Now 5 are basically done and you want to move those 5 files to some safe area, which is basically a staging area. In order to move those 5 files out of the 10, you use the git add command. So git add command will move those 5 files from your working directory to the staging area. Now, what happens is that 5 files are in the staging area and the remaining 5 where you are still working are in the working directory. Now, your 5 files are ready to move further to the local repository. What you can do is that you will simply use the git commit. Here, the commit number will be generated and your files will be moved from the staging area to the local repository. Now, once you have finalized everything is good to go to the remote repository, then you will be using the git push command. Now, git push command will move the files from local repository to the remote repository. Now, in this scenario so far, we have started with the 10 files. We are still working on the 5 files. The 5 files are still in your working directory, and the 5 files where you are showed, you move those files from working directory to the staging directory, and from staging directory, you move those files to the local repository, and from local, you push those files to the remote repository. Now, your team member, either is a developer or automation engineer, they added 5 files and they push those files to the remote repository. Now this remote repository contains 10 files, 5 files from your side and 5 files from your colleague. Now there are 10 files. Next day, you come to the office. Now you want to those changes or those files so that you can continue your work. So how you will work on those? So simply you will execute a git pull command. Now what this git pull command will do basically, it will fetch the changes and bring those changes to your working directory. Now your working directory have all the 10 files, 5 files from your colleague and 5 files on which you are working. On the behind, what happens is that when you execute a git pull command, so basically it executes two commands. One is git fetch. It will bring the files from the from the remote repository to the local repository, and then it will execute the second command, which is git merge. Git merge will automatically merge those changes to your working directory. So on the behind, when you run the git pull, it will execute those two commands, git fetch and git merge. Now let's take another scenario where you want to see which files has been changed, either you really need those changes or not. So in that case, what you will do is that you will manually write the command called git fetch. It will bring the changes or the new files from the remote repository to the local repository. Now here you have a chance, either you want those changes into your working directory or not. If you don't want, you can discard those changes from here. And if you really want those changes of the files, then you have to execute git merge command. Now this git merge command will basically move the files from the local repository to the working directory, right? So git pull, and then we have git fetch and git merge. Now we have another scenario basically where you have joined a team and you're starting a work and you want to collaborate on the project. So basically what you will do is that you'll execute a git clone command. Okay. So git clone will give you a copy from your remote repository to your local repository, right? And if you want to work on any specific branch, in that case, we usually use this git checkout. So if I summarize this high level workflow of the files, so basically you will be using a git add command. This will move the files from your working directory to the staging area. Now you want to save those changes which are already on the staging area, then you will be using the git commit. So git commit will save the changes, right? And in case of the git merge, so basically it integrates the code. Git fetch will bring the changes to the local repository, then merge will basically integrate the code with your local working directory, right? Git fetch basically here will bring the latest changes till local repository. Here you have a chance. If you want those changes, then you have to execute the git merge. But in case of git pull, it will get the latest and merge. So you don't have an option. If you execute this command, it will bring the latest changes and merge those changes to your working directory. And git clone will basically download the repository here. So here, these three things, three like working directory, staging area, local repository, these all are basically on your local machine. Here, remote repository is basically on any cloud server like GitHub, GitLab, Azure DevOps, where team will basically collaborate. So on the daily basis, you're working on some files, you're moving some files from your working directory to staging area. Once you're ready, you commit those changes with the commit number and the current message. Files are here. And finally, you think that you're good to go with the push, then you'll execute the git push command. It will push your local changes to the remote repository, and from there everyone can collaborate, right? So that's how the basic git workflow works. This is how the files move across the different git stages. So in our upcoming tutorials, I will show you these things practically, how we are moving from git add, how we are moving from working directly to staging using the git add, from staging area to local repository using git commit, and similarly how we can push. But mainly in this series, we'll be focusing on these local things, and then we will see that how we can move or push our code to the remote repository. Hello everyone and welcome back to the channel. In this particular session, we will learn about the best practices around git add and git commit. We will learn to write the clean commits for the test automation. So this would be a complete practical step-by-step tutorial. So let's begin. First, let's take a scenario to understand the importance of the git commit. Your production is down. Now your team is scrambling to find exactly when the critical relation was introduced. Someone opens the Git log and sees something like this. Now, nobody knows what was changed, why it was changed, and what happened exactly. So, this kind of commit history is useless. Now, imagine another team, which is disciplined one, and their Git history looks like this, where they have a proper messages, and you can see that add a regression test for the coupon code edge test case. Now, after looking into this one, team can easily understand what happened, who made the changes, and what changes were made. Based on this, they can roll back the changes, right? So, as a tester or a developer, your commit are basically your professional signature. So, clean commits don't just help developers or the testers; they help you to trace bugs, document evidences, and communicate clearly with your entire team. So in this tutorial, I will teach you exactly how to do it from the scratch. So what we'll do is that I will create a new project and a folder and we'll start working on it. So simply let me go here and let me create a new folder. I'll say demo git and open this folder. This is an empty folder right now. And once you are there, just right click, go to more options, click on Git Bash here. You will see this kind of a window here. And let me increase the size so you can see what I am writing. Right now, you see that we don't have anything inside this one. The first thing which we need to do is that we need to initialize the Git. Okay. So now what we need to do is that we need to tell Git to start tracking this folder. So how we can do this? We say Git init. Now you see that we have a message called initialize empty git repository here slash dot git slash folder, but we don't see anything here. So what exactly happened over here? So git created a hidden folder. Now this is a hidden folder which is dot git slash inside your main folder. Now this is the git's brain. It will store all your history, configuration, and tracking data. You will never edit this folder manually. Keep this in mind. Okay. Now, the first thing, the very common git command we use on the daily basis is that to check the status. So, git status. And as soon as I press enter, you see that on main branch, no commits yet, nothing to commit. So, what it means, so on main branch, so you are currently on the main branch. Okay. No commits yet. So this repo has zero commit history. We have nothing committed so far. So there are no files for Git to track yet. So nothing to commit means that there is no files for the Git to track yet. Now think of Git status is like checking your test environment before running a test suite. It tells you the exact state of everything. So run it constantly before staging, after staging, before committing, after committing. You will exactly know the status of your project and the files. Now let's create a file inside a folder. Let me go here, simply right click, go to new. Let me create a text file, name it as login test. And inside this one, I'm just writing test and save this file. Now we have this file inside this particular folder. Again, go to git bash. Again, type git status. And here we see that we are some files which are untracked, nothing to add commit. So what it exactly means? So basically Git can see. So untracked files means that Git can see these files exist in your folder, but it is not watching them yet. So use git add. So basically Git is literally giving you the next command to run and nothing added to commit. So basically the staging area is still empty. So we are still in our working directory. Now what we'll do is let's add this file. So simply git add and name of the file, which is login test.txt. So as soon as you run this command, so there will be no output. Silence means success in Git. Now we need to verify this thing again. Run git status. Now you see that the expected outcome was like on main branch, no commits yet, and we see this changes to be committed. So what it means? So it means that now our file is on the staging area and ready to be, committed. So think of staging as arranging everything on the table for inspection. And then you are saying these are exactly the changes I want to record to the commit, right? Now let's create another file over here. So new file, and I will say sign up test and press enter. Open this file and name test. Save this file. Go back here, and now I will type again git status. Now again you see that our one file login.test is ready for commit, which is on the staging area, whereas Git is saying that the sign up test file is still untracked. So in order to move this to the staging area, again we need to use the git add command, right? So we are seeing both the things, right? So basically login test file is staged, and the one which is sign up test is still in your working directory, not on the stage, right? Now let's move the second file to the stage. So git add name of the file sign up test.txt. Now this file is also being added, so let's verify it. So git status, and now you see that we have both files moved to the staging and both are ready to commit, right? Now, this is the more important section of the tutorial where we learn to write the clean commit messages. A commit message is a permanent record. So other engineers and automation tools all read the commit messages. Writing the lazy commit message in the Git equivalent of writing a bug report that just says something broke, right? So we need to give a proper commit message. Okay. So the good commit message have two things: type and scope. So we need to be very much clear what is this all about, what we have done, right? So when we talk about the conventional types of for the testers, right? So what we'll do is that when we commit, we say that this is a login test. We added a test case for maybe a valid username and password. For sign up, we have fixed the broken test, right? But that commit message needs to be very, very appropriate so that other person can understand, right? So what we'll do is that we can simply commit this one, git commit dash m, and here I need to provide the commit. So there are two files, right, which are ready to commit. So I'll say test login, right? So what I'll say, added initial, or maybe added the most appropriately small test, and we have sign up. So sign up Like again, we have, if this is a test, so we'll say test, then the bracket we'll say, again, you can use any formatting, but the purpose here is that the idea is that it should be very clear what you have done. So sign up, and here, for example, what we did is that fix the test case, and test case ID is equals to TC maybe 001, right? And after that, just press enter. Now, these both files now got committed with this proper message over here, right? And if you look into this one, so it says that two files changed, two files insert. So what is changed? So basically two files inserted, right? And both files were included in this commit. This is a commit number. And if there's a number of lines, you will see the number of lines being changed or added on this one. Okay. So right now, two insertions means two lines, two files, two lines inserted. And this is the git commit number. Now, again, let's verify this one. Simply say git status. And now our main branch is clean and nothing to commit, because the files which we were working on are committed and they are ready to be pushed to the remote repository, right? So what we did is that we created a project. We initiated a git over there, created a file, added those files to the staging, and from staging, we moved those files to the local repository. We committed those files. So as soon as we commit, so we get these details with the commit number. And here, the most important thing is that writing a proper commit message so that your team understand what exactly you have done in this particular thing. Now, obviously, you can change the things, you can add more files. So moving forward, we will see how you can work more effectively with the Git. Hello everyone and welcome back to the channel. Now imagine a test suddenly start failing in your project, or some features start failing suddenly. You open the test file or the code file and wonder who changed this, when was it changed, and what exactly was modified. Now, instead of asking the entire team, Git can tell you everything in seconds. In this tutorial, I will show you how to use Git Log to view commit history. So let's begin. In our previous tutorial, we learned how to add files and create commits. So we were using these two files at that time. Now we will see that how we can track and view commit history using the Git log. So the first thing what we need to do is that right click here, go to show more options, click open Git bash here. Let me increase the size so that you can see what is happening over here. Increase more size here. So the basic command is basically a git log, right? So simply we'll go and run here git log. So before executing this command, there must be some files which are committed so that we can see the commit history. So if you are following this series, ensure that you have added the files, you have committed the files. If you haven't done this, just go and check my previous tutorial on this one and then come back here. Now, once you have committed the files, simply write a git log command. So this is a very basic command and press enter. So as soon as you execute this command, so what happens is that you get some information over here. And here, what you will get. So basically, you are saying the commit number. So this is the commit number. Who was the author? So I was the author here. And when did I made this commit? So 12th March at this particular time. And this was my commit message. So I added smoke test and the sign up test. And this is a description of this particular test. So by looking into this one, I can easily understand that who made what changes. So it would be easier for we to decide the rollback if needed. Okay. Now, if you need a one-liner commit or one-liner log, so what you need to do is that simply type here git log dash dash one line and press enter. Now this is a summary of that particular commit. You have commit number and here's your commit message. Again, this would be really helpful to understand what happened in this particular commit, right? Now you can also limit the number of commits. So if you have done 5 or 6 commits, 100 commits, but you want to understand what happened in last 3 commits. So far, what we did is that we have only one commit, but there are more commits in your project. You can limit the view. You can limit the number of commits. So simply how you can do this, for example, git log dash 3, for example, you need the last 3 ones. So press enter, so it will give you last 3, but right now we have only one commit so far, so that's we are getting 1. If there are 3 or more than that, you will see all those 3 over here. You can use a similar command for the one line explanation. So git log dash dash one line space dash 3. So you can also run in this way. So you will get the summary or the one-liner commit history for last 3 commits done. Okay. So what else you can do? You can view the changes in the commit as well. So how you can do this? Simply git log dash p. So now you see that this is the commit number, who was the author, when this change was done, what was the commit message, what was added, which files were modified, which were added. So new line added at the end of the file. Here we have added this one. So we see what exactly happened. So plus means line added. If I have removed some lines, so it will show minus sign. So plus means I have added this thing, right? Now, what else you can do? You can view the history of specific files. If you see that previously one developer or automation engineer added a one specific file, right? Now you want to see the history of a specific file. So how you can do that? So simply what you can do, git log and the name of the file. So let me go with this login test file. So login test.txt and press enter. So now we are getting the commit history for this particular file. Again, the commit number, author, date, and the commit message, right? What else you can do? So basically, you can also go with the graph. So these commands basically, you can use the graph as well. So it will give you some graphical representation of the commits. Right now we have one, so I'm not going into that one right now. But before ending this session, let me summarize the commands we have learned. So we learned git log, a basic command. Then we learned git log dash dash one line, so that the summarize of one-liner history. Then if you want to view last 2 commits, so basically git log dash the number of commits you want to see. If you want to know about the particular commit, so git log dash p. You want the history of a specific file, so git log and the file names. Now these commands help the testers or the developers to track the changes, investigate issues, and understand the project history. Hi everyone and welcome back to the channel. In our previous videos of this Git series, we learned what Git is, how Git workflows work, how to add and commit code, how to view commit history using Git log. But here is a very common situation engineers face. You commit automation code or the development code later it fails. Now the question is, which line of the code changed? What exactly was modified? What did my teammate update? Instead of manually checking the files, Git can show you the exact change instantly. And the command that does this is Git Diff. In this video, we will learn Git Diff step by step with the practical examples. So let's begin. Before understanding the Git Diff, let's connect it with the concepts we already learned in this series. So in our previous sessions, we learned that there are three Git stages: working directory, staging area, local repository. And we also learned that how to use the Git add, how to use Git commit, and finally we learned that how to view the Git commit history using the Git log. Now the missing piece is how to see the exact changes between the versions. That's where Git Diff comes in. Now what is Git Diff? Let me open a notepad over here. And so basically, Git Diff shows the difference between two versions of files in Git. So basically, it shows the difference between two versions of files in Git. It basically tells you what lines were added, what lines were removed, and what lines were modified. So think of it like a built-in code comparison tool inside a Git. Now let's do it practically. Let me minimize this one. Let's create a file in this project. So go here and create new file, and I'm naming it as login test diff, and inside this let me write login test and save this file. Now what we need to do is that we need to add this file, then commit this file. Okay, so git add dot and now run git status. So on the main branch, changes to be committed, so we can commit this particular file. Okay, so git commit dash am, and my initial commit is basically initial login test, and press enter. Now git status again. So you see that nothing to commit, working clean tree. Now what we will do is that we will add one more line to this particular scene file. So what I'll do is that let me open this file and say added slash modified login test and save this one. Now here comes our git diff. So git diff. Now it will show you the details over here, right? So basically we have these changes. So we have this one and this one. Okay. And now what we need to do is that we need to understand what it means. So basically it says difference between git a, this file, and this test file. Now one is this change is basically done on your working directory and the previous change is already committed. So that's why it's giving us a difference, right? What is minus, what is added, we see all these details over here. Now in order to check the the differences, or you can compare the specific file, so what you can do is that you can run command called git diff and the name of file login test diff. So here it says unknown version. So basically we need to provide the extension. And now you see, so in case if you are working on the multiple files, especially you're working on large automation test suite or maybe developing a large application, so in that case you might need to see a difference in a specific file. So that's how you can do this. Now again, add the changes which we have done in the working directory. So git add, and the file is basically login test diff.txt. Now for this added, again git status. Now this file is ready to be committed. So if I run git diff, you won't see anything. Nothing appears here. The reason here is that because changes are already staged. To see the stage changes, what we need to do is that we need to use git diff dash stage. Now you will see the changes in this particular file. Now what you can do, you can compare the current code with the last commit. So how you can do this? So simply git diff and head, right? So you can see the details over here. Even what you can do is that you can compare the two commits as well. So for that, git log dash one line. So you see that we have two commits. One is this initial and this second one. So we have these commits, right? But this commit is not related to this particular file. So in our previous session, we learned that if we want more commits, so what we need to do is that we need to provide the count, for example, 4. And still you see that we are getting the commit, because the reason here is that we still haven't committed this file. So in order to compare the commits, so you need to commit the file. Okay, so git status, and this file is ready to be committed. So git commit dash m updated test. Now this is basically committed now, git status, and nothing is basically to commit working tree clean. Now if I run this command, so initial commit was this and updated was this. And if you want to see the difference between these two commits, you can simply type git diff and both the commit numbers. So copy this one. So let me copy the commit numbers here. So this is the first commit and this is the second commit. All right. So basically command would be git diff and this. So let me copy this one and let's paste this over here. And we don't need this one. So simply remove this one and press enter. So here you can see the difference between the two commits. So in real automation QA scenario, you run this git command difference to show what was happened, right? So imagine your automation test suddenly fails, you run git diff and git shows that the timeout was 5 seconds and previously, and now someone changed to 30 seconds. So that might be a problem, right? Now you instantly know someone increased the test timeout. Without Git Diff, finding this change would take minutes. So with Git Diff, it takes seconds. So there's a pro tip for developers and QA engineers. So before committing code, always run git status, git diff, then git add, then git diff stage, then git commit. So this ensures you commit only the intended changes. So let me summarize this tutorial. So basically, git diff helps you compare code changes, see modified lines, review stage changes, compare commits, debug issues quickly. So most important commands were in the session we learned this basically git diff, git diff with the file name, git diff dash dash dash, git diff. Hello everyone and welcome back to the channel. So have you ever committed something in a git and instantly you regret it? Maybe you have pushed the wrong code or deleted something really important. Now, what if I tell you with one command you can undo the commits? But there is a warning. One wrong reset and your code is gone forever. So in this video, you will finally understand about this Git reset and the different types like soft versus mixed versus hard. So let's begin. So far in this series, we have learned about Git workflow, Git add, Git commit, Git log, Git diff. Now it's time to learn one of the most powerful and dangerous Git command, which is Git reset. So in this video, you will learn what Git reset actually does, difference between the soft, mixed, and hard reset, when to use each one, and let's simplify Git reset once and for all. So for a quick recap, Git has the three main stages. Remember, working directory, staging area, and repository, right? So now what this Git reset do? So let me open the notepad and here let me write. So git reset. So what is actually do? So git reset moves your head backward to a previous commit. So basically it reset moves basically git reset moves your head backward. So moves your head backward to a previous commit. Backwards. Right. So there are basically three different types. One is soft, right? One is basically a mixed and other is a hard. So let's understand these one by one first. So let's talk about git soft, reset, soft, reset, reset, right? So basically how you can use, you can basically, it moves only the head. So only moves head and it will keep the changes in the staging area, right? So it keep changes in staging area. And how you can use this one? So simply the command is git reset dash dash soft, then hard, and then this sign and then one. Now, question is that when we should use this git soft reset. Okay, so you want to undo a commit, but you want to keep your changes in the stage area. In that case, only you would be using this particular git reset, right? Now, the second one is basically a git mixed, basically git mix, and it moves, right? Okay. And basically removes changes from staging. So if it's removing the changes from the staging, like the soft reset, then what is the difference, right? So basically, it keeps the code in the working directory. So keeps code in working directory. And the command is basically again very simple. So git reset head and this. That's how you can use this command. And the question here is again when you should be using this one. So simply you want to re-edit or restage the files. If you want to re-edit the file or restage the file, in that case, you should be using git reset, right? Now, third one is basically a hard reset and is basically a very dangerous command. You need to be very cautious when you're using this command. Okay, so git hard reset. So question is that what this will do. So it will move head like above resets, okay, and deletes stage changes, and it will also delete the working directory changes. That's why it's really dangerous. So it deletes working directory changes as well. So that's why it's really dangerous. So you need to be very cautious about using this command. Now, when you should be using this one, so you should be using this when you completely want to remove the changes. Means that you want to remove the changes from staging and your working directory where you are 110% sure that you don't need this command at all. So in that case, you should be using the git hard reset. Now, let's go here in my bash, git bash over here. So first, let's run. So we have already previously we have some commits, some files which we have created during this particular tutorial series. So simply I will run git log dash dash one line. So you see that previously we have done 3 commits, right? So if I want to do a simple soft reset, right? So this is the in order to do that, simply git reset and then dash dash soft, then head, and this one. And now let's run the same above command, right? So you see that here, this was our latest commit, and this is now no more part of this one. Okay. Now if I run git status, so nothing is there, right? So on main branch, changes to be committed if we want to do that, right? Now, if we want to do the mix reset, so simply what I will do, but before that, again, let's run this command. And here, what I'll do is that simply run the git mixed reset command. So git reset head and one. And if I run this command again, so you see that only one commit left over here, right? Now let's see how git hard reset work. For that, what I do is that let me create new file git reset and let me add test. Then let me create one more file over here. Git reset And let me add text over here. Save this one. And now go back here. And the good practice is that always use git status to see what is happening. So these are the files, right? And I will say git add dot and then git status. Now these are files which are ready to be committed. So git commit dash m new files added, right? And if I run this git log, you see that now we have two commits. One, because we have already reset using the soft and mix file. So that's why we are seeing only the two commits, the one which we just did and the one previously remaining, right? Now, let me add one more file over here. New file. And let me add something inside this. Save this one. And again, we will do git status. This is a file and git add dash. Then git status. This is a file which we can commit. So git commit. I will say hard reset demo. And now if I go and hit git status, so our branch is clear, nothing to commit. Then if I run again this command, so you see that we have 3 commits over here again, right? Now what we need to do is that we need to run the git reset hard command. Okay, so again, you need to be very cautious when you are executing this command, right? So git reset dash dash hard and head 1. Remember what is our last commit? In the last commit, we added this particular file, right? So if I enter this one, it says that head is now at this one, right? New file added. And you see that it even removes the file from the working directory, deletes everything, staging from working directory. That's why we need to be very cautious when we are executing this git hard reset, right? So basically, if we talk about this particular tutorial, what we have done is basically we learn about the git reset, different types of the git reset, where we have soft, mixed, and hard reset. And basically, if we talk about this one more thing really important over here. So never use hard reset on the shared branches like main, right? Right now I'm showing demo on the main or the develop branch, but never do this. You can break the team history. So instead, you should be using a revert. I will cover that in our upcoming tutorials. But as of now, because my purpose was to make you understand how git reset works. But in ideal cases, if you are on the main or develop branch, don't use hard reset, right? And if I talk about real QA use cases, so as a QA tester, you will use to reset when you committed the test script too early, wrong test data post, need to clean the commit history. So reset helps you to maintain the clean automation. Hello everyone and welcome to the channel. Have you ever made a mistake in Git and thought, how do I undo this without breaking everything? In this tutorial, we will clearly understand what is Git restore, what is Git revert, when to use each with the hands-on example from scratch. So let's begin. So let's start with creating a file. But before that, let's right click over here in the project, show more options. Click on open Git bash here. Let me increase the size so that you can see here properly. Now, what I'll do is that let's create a file first. So I will go here, new file. Let me name it as Revert demo. Okay, and let me add some text and save this file. And now just go here and simply type git status. And here you see that this is a file which is untracked so far. So what we'll do is that we'll simply go here, git add the capital R revert demo.txt. Now again git status. So this is the file which is ready to be committed, and simply I'll say git commit dash m, and this is initial commit. So the file is committed now. So if I go again here and type git status, so you will see that nothing is there working directly. It's clean. Now let's understand the concept. Okay, why we need to do the revert, why we need to do the, we go with the restore, right? So we need to understand these concepts very clearly here. Now assume that by mistake you have modified the file. Okay, the file is committed and you have modified the file. Now you modify the file in your working directory, but you have also committed the file with the previous information, right? So how you deal here? For example, you have done this modification mistakenly, or you really don't want to do it, then what do you do? So if I go here with status, so it says that this file is modified now. Okay, and if I write git, git diff, so we can see the difference. So this was added and this was basically removed from the file. So initially this was the text inside that particular file, and after modification this was the text. We can see the difference, right? So we have already understood how to use a diff command. Now what is git restore? So if I go here and let me go here, so git restore, what this is, and again let me increase the size. So basically git restore is used to undo local changes, not the committed, which are not committed yet. So basically used to undo local changes which are not yet committed. So basically not committed yet. So we have made the changes, but this is not yet committed, right? So now this is safe for fixing the mistakes before the commit. So save for fixing mistakes before commit. Okay. Now how you do this? The command is very simple. Git restore, and the name of the file. So basically here we need to provide name of the file. So let's go here into the git bash here. Simply git restore. Now the name of the file is basically revert demo.txt. And if I go here, git status, nothing is there, right? But if I open this file, you see that it has been restored to the previous one. So we made the mistake and we corrected that mistake using the restore. So you need to use the git restore, and this is helpful because you can undo the local changes which are not yet committed. So this is safe for fixing the mistakes before you commit, right? Now, if I go here, so file is back to the original state. We have already seen this. So important concept here is that you edited a file by mistake. You want to discard the changes. Changes are not committed yet. So you need to keep these 3 points in your memory so that tomorrow, if something you done mistakenly on the working file, which was previously committed, so you can easily do the revert, or you can simply restore that file. Now, the second concept here is basically about the git revert. Okay. Now let's create a committed mistake. So what I'll do is that I will create a file and then we'll add that to commit this one. So simply let me create one new file and let me name it as revert demo1, and let me add something here, beta, and simply if I go back here, git status, then git add, then git status again, and let's do the commit first. So git commit dash n added wrong stuff. So the file is committed, and if I go here, git log dash one line. So we see the history of all these commits. Now, what is git revert here? So if I go here, let me type git revert. So used to undo a commit safely. In the previous session, we made the changes which we done in the working directory, right? Hey, this is the difference, right? So used to undo a commit safely. If you want to, reverse this thing, you have done mistakenly this commit, right? In this case, you will be using again. Let me write this one: git revert used to undo a commit. Now, what it will do basically, it will create a new commit that reverses previous changes. So this is the best for the shared repos like the QA teams or the QA projects, right? And how you can do is that basically the command is git revert head. So this is a very simple command. So let's go here and use this command git revert head. Now just review these things and simply press escape and then colon WQ and press enter. Now you have come out of that editor and you have successfully done this revert committed. Okay. Now what we need to do is that if we go here and type git status, so everything is clean. Just go here, git log again, right? So you see that this revert commit has been created over here, right? So basically, if you see the difference between the restore and revert, so basically git restore is worked when you have uncommitted changes. You will be using git revert when you have a committed changes. If you look into the git restore, so there is no impact from the history change because there's no commit done. But in case of git revert, you can see that we have commit history, right? So it creates a new commit. So this is the new commit, right? Now, if we talk about the use cases, so git restore is very useful when you have to fix the local mistakes, means working directly. And when we talk about the git revert, on the other hand, so basically you can undo the pushed or committed code. So if we talk about the real uh, tester or QA automation engineer use cases, so git restore when you edited a test script wrongly. You want to discard local changes quickly. You use git revert when you pushed a wrong test cases. You broke the CI/CD pipeline. You want to save undo without affecting the team. So these are the real use cases for the automation engineers. The common mistakes you need to avoid. The first one is that using git reset instead of revert in a shared repo. Use git reset instead of a revert in a shared repo. The second thing, trying to restore after a commit won't work. So reverting wrong commit, always check git log, right? So these were the tips which are really helpful for the automation engineers. So always use the proper command, when to use git reset, when to use git revert, when to use git restore. I hope now you have a clear understanding between git restore. Hello everyone and welcome back to the channel. So in the real projects, developer write the features, QA testers write the automation scripts, developer fixes the bugs in the parallel. So how does Git manage all this without making any mess? So the answer is really simple, using the branches and merging the code. In this tutorial, you will learn what is a branch, how to create and switch the branches, how merging works, and real QA use cases. So let's begin. So what is a branch? Think of branch like a copy of your project where you can safely make the changes without affecting the main code. So let me give you an example over here in terms of the folders. So for example, I'll create a new folder over here and name it as main. So this main has the files. Assume that it has all the updated code, right? Let me go here and add few files. Simply go here and name file add. Okay. And now what you can do is that you can make a copy. So in terms of the Git, we call it as a branch, right? So I'll copy from here and paste it over here, and let me rename it as login test. Now when we create a branch, So we have all the changes because we have created from this main folder. We copying the main folder, so we have those in the other folder as well, right? Now you have a copy where you can add the new code. So simply what you'll do is that you'll go here and add your new code, for example, sign up or the login test. And now once you have added, because now you have added into a folder which is login test safely, because you're not touching the main folder where we have a stable code, where we have a working features. So we are not messing up with this one. So what we did is that we create a copy of this main, and inside that we have adding our work safely. Now once this work has been done, so simply in terms of the gate, what we do is that we merge this into this one. So basically merge will check the changes and all the code will be merged into this main. So this is how basically Git merging or branching works. And this is how the development team or the QA engineers work in parallel, right? So usually in terms of the coding, so main is basically a stable or the tested code. Then you can developers can create the branches for adding the features. QA automation engineers can create the branches for writing the test cases. Even in a similar way, developers create for the bug fixes. Automation engineer create for updating their scripts, and everyone basically work independently without breaking each other's work. And once the work is done, they finally merge that code into the main. So that's how basically branching and everything works. So what I'll do is that let me go here and let me delete these rows, and let's see the real-time Git things over here. And simply go here and Git bash over here. And by default, there's a one branch which is main. So you are on the main branch right now. And if you see that how many branches you have locally, so simply type git branch, and you see that you have one branch which is main branch, and currently static means that you are in this branch right now. And we have already these files. So what I'll do is that let me create one new file here, and I'll say main branch, and let me add some text over here. Save this one, go here, git status. So on main branch, so we are on the main branch right now, and this main branch has this file, so which is untracked. So git add and then git status. Then let's do commit. So git commit dash m, and I'll say initial commit. So again, git status. So we have committed this file. Now again, if I go to git branch, so we still have the main branch only, and we are on the main branch. Now you can create the branch from the main branch because you need the work which is done by the team members, right? So you need previous work. So in order to get that one, so we create the branch. Okay. So there are different ways. So you can simply use the switch command, git checkout command, git branch. So in order to create a new branch, so you say git branch and name of the branch. So for example, feature dash login. Now this branch has been created. Again, I will type git branch, and you see that there are two branches, main and feature dash login, which we just created. Now in order to switch to the branch, what you can do is that either you can write git switch or git checkout, both works. So simply git checkout feature dash login. Now you have switched to the branch, which is basically the feature one. And again, git branch. So now you see that you are on the feature login branch, and we have two branches right now. So now, as the real-time practice, what we'll do is that we will be adding the feature file over here. So like we do here, go and say feature login. And again, let me add one thing over here and save this one. And again here, git status. So in this branch, we have this untracked file. And if I go back to the main branch, git checkout main, and if I type git status, so you see that this is file. Now you have two separate branches. Now where you want actually to this file to be tracked, right? We need to tell the git, right? So again, we need to go to our this checkout branch, and once we have this one, so in this particular branch, I want to track. You have two branches, and where exactly you want to be tracked. So that's how you want to tell the git, right? So simply I will say git add and then git status and then git commit dash m feature logging added, and now file is committed over here. Okay, and this file is basically tracked and committed in this branch, not in the main. Okay, so if I go back to the main branch, so git checkout main, and if I type cat and then the name of the file, which was basically, even you can see that this particular feature login is not available over here, right? So if I say cat feature login dot txt, so it says no such file available in the directory, because this means that we have created a file inside the branch, committed the file over there. That's why this file is not available in the main branch, and we have confirmed that the file does not exist in this one, right? Now here the point comes that we need to keep update our code. So my changes needs to be merged into the main, because main is usually the stable branch where the code is tested. So everyone should have the updated code. So how we can merge? So simply git merge. We are on the main, right? So we are on the main branch and we want to merge the feature login branch, right? So we again git branch. So we are the main branch and we want to merge the changes from feature log into the main branch. So how we can do this? Simply git merge and the branch which we need to merge. So feature dash log and press enter. Now you see that this feature.login, we see this file over here, and this file is added. And again, if I run this cat command, so you see that this file is there now in the main branch as well with this following text. So in the real time, what happens is that either you want to do a new feature, you want to create the new scripts, you want to do bug fixes, hot fixes, any kind of things. For that, what you need to do is that you simply create the branch, add the files, modify the code if needed, and then merge back to the main branch. So this is how you create the branches and merge the branches. And in terms of the QA tester workflow, so usually you have feature login and you developer work on it, then you created a branch for the login test, automated the script for the login feature, and merge that right into the main safely. Here's a common mistake you should avoid. So working directly on the main, you should not be working directly on the main. Forgetting to switch the branch, again, this is a problem most of the developers or the automation engineers, what they do is that they forget to change the branch and they start working in the same branch. So always ensure that you are working in the same branch. Okay. So ensure that you're working on the right branch, not pulling the latest code. Don't panic when the merge happens, right? And the basically, the key commands which we have learned is that git branch, then git branch name, git switch, git checkout, git merge. So they were the basic command which we learned in this particular. Hey everyone, welcome back to the channel. So have you ever see a git suddenly stop your merge and throw a scary message like conflict? Don't worry, in this video I'll show you exactly what a merge conflict is, why it happens, and how to fix it step by step using a real QA project example. By the end, you will be confident in handling the conflicts in any team environment. So let's begin. So what is a merge conflict? A merge conflict happens when two branches modify the same part of the same file. So basically, two branches modify the same part of the same file. Let's take a scenario where a tester one created a branch for login test and added a file, added a complete script for automating the login functionality. Now another tester comes in. That tester creates another branch and added maybe a login test or modify the same code due to any reason, maybe updating the locator, maybe adding the more sessions which are more appropriate in terms of verifying the login functionality. Now what happens? Now there are two different versions of the same code here. Now when the second tester tries to merge that into the main, what happens is that Git will basically confused. Git cannot decide and basically which version is correct. So Git will pause here and it will basically ask you to resolve it. Now when we talk about the Git merge conflict, so basically merge conflict is not an error. It's a decision point. Maybe both codes are in the working state. There's no error, no exception. But what is the right code which needs to be there? Here you need to decide and you need to resolve that conflict before you commit the code. So far, we have learned branching, commits, and workflows. Now, let's see what happens when two testers work on the same file, which is very common in the real QA projects. So let's go here. And this is a folder we are using throughout this series. Simply right click, more options, and just bash here. And let me increase the size, right? And what we need to do is that let's create a file here first. And let me go here, new text file. And let me name it as test dash login. Now, just open this file. I will write something. So I will say login test case. And here we have assume that you have a steps for this particular automation script. So I'm writing it as a plain text, but in actually you will be writing the script. So enter username, then enter password, and finally click login. So this is the first initial version. So let me save this file, and if I go here and type git status, so you see that this is a file which needs to be tracked. So simply I will say git add dot, and then again git status. Currently we are on the main branch. So this is a file which is ready to be committed. So simply I will say git commit dash m. I'll say initial commit, right? And press enter. Now this file is committed. If I go here again, type git status. So there's nothing, and we have a working clean directory, right? Now what we need to do is that let's create another branch. So I will say git checkout dash d, and I will say feature dash login dash update, and then press enter. So it says already exist. So I will say update dash new. So now we are in this particular branch which we have created, and simply what we'll do is that we will update the same file and same code over here. So enter username, enter password, click login, and here the verification is missing. So I will say verify dashboard page, and save this file, and again go back here and say git status. So this file is being modified. Here you can see that, and now just go here, git add dot, then git status, and commit this file. So basically git commit dash m, and I'll say added a dashboard verification, added a dashboard verification. Okay, and the code is committed over here, right? Now what we need to do is that we need to go to the again to the main branch. So how we can do this? Simply git checkout main, and now we are back to the main branch again. Now what we need to do is that we need to modify the same file, and I will update this part of code over here. So I will go here, I will say verify error message. I'm just updating the assertion. Verify error message for dashboard, and save this file. And if I go back here, we have done this. So simply again git status. Again, this file has been modified. So git add dot, and then git status, then again git commit dash m, and now I'm doing this change in the main branch. So I'll say updated the assertion for login, and press enter. Now you remember that we made some changes when we created another branch. Now already main branch is there with the modification, and we have other branch. So let's try to merge that feature branch. So git branch, and here we have this feature login dash update dash new. So git merge, and here feature dash login dash update dash new. So I'm merging this feature login update new branch into the main branch and press enter. So you see that auto merging this one and conflict. So merge conflict in this particular file. Automatic merge fail, fix conflicts, and then commit the results. Now, what happens basically? So Git try to merge automatically, but both branches change the same lines of code. So Git stop and ask for the manual resolution of this one. And if I type Git status, so you see that you have unmerged paths. Okay, so this is there, right? Now, what we need to do is that we need, just let me close this file. And if I go back here and open this file, so you will see something different. We have this head, we have this arrows, this line. So what it means? So basically, this particular line is basically called as a conflict marker, and it tells that your current branch is basically a main branch. It refers to a main branch. This part of code refers to a main branch, and then this is a separator, and after separator, this is the incoming branch code. Now Git shows both versions. You have to choose what is the correct and what should be there in the file. And how to resolve this conflict? Simply, we have already opened this file. We need to remove these markers from here. And for example, you want to keep this particular line. So I'll remove this part of the code. And you just remove the unwanted code and simply save file. So this is how it is easy to resolve the conflict in your code. Now, once you have saved this file, again, let's go back here and let's go to git bash. Say git status and then git add dot and git status, and this is the file. And now let's try to merge commit this one. So git commit dash m. Now important thing is that when you are resolving a conflict, your commit message should reflect that you have resolved the conflict and provide as much details as you can. Okay, so right now I'm just saying that resolved merge conflict in test dash login dot txt and press enter, right? So you see that we have successfully committed this one. This is the commit resolve merge conflict in this one. So you have successfully resolved that commit, resolve this conflict, and you have committed this file. Now just type git log dash dash one line, and here we get all the information. Resolve merge conflict in this one, right? And in terms of the real QA scenarios, what happens is that QA updates positive test cases, then QA2 updates the negative scenarios. Both modify the same file. Conflict during the merge happens. Now, this is extremely common in the test case documents, automation scripts, test data files. Now, what are the best practices you should use? So, the first point is that you always should have a latest code. So, always pull the latest code, git pull origin main. This is a command you need to remember. This will give you a latest code. Now communicate before adding the shared file, because this is a shared file. More than one people actually modify the same part of or same line of the code. So before resolving the commits, communicate, have a discussion with your team member why they have added this, so that you can decide the final code. And once you have decided the final code, resolve conflicts immediately. Okay. In case if you want to abort this particular merge, so simply the command you need to use is that git merge space dash dash abort. Okay. So now you know exactly what is a git merge conflict and how to fix it step by step. This is one of the most important real world Git skills every QA tester must have. So if you have any questions, any confusion regarding this Git merge, just go to the comment section, add your question, and I will try to revert back to you as soon as possible. Hi everyone, welcome to the channel. Have you ever started writing a new test automation script and suddenly a high priority task comes in the middle, but your code isn't ready to commit? Today, I will show you how to use Git Stash to save your unfinished automation scripts safely and switch tasks without losing a single line of code. So let's begin. First, let's create a file here in this particular folder. So right click, go to new, go to text document. I'm naming it as stash demo and open this file, and I'll say this is first line of code. Save this file and then come back here, right click, go to show more options, open git bash here, and let me increase the size so that you can see what is happening. Currently we are on the main branch, so as per the regular practice, type git status and you see that we have this file over there, and in our previous tutorial we created this file. So don't worry about this one, just focus on this particular file which is untracked right now. So just type git add dot and again git status. So you see that these files has been committed. So these files are ready to be committed. So git commit dash m added new stash demo file. Now code has been committed. Now what we need to do is that we need to see the commits. So simply git log dash dash one line. So here you will see the commit on the top. So this is the commit number which we have done right away. And now what we need to do is that we need to go back here, and let me close this file first and then go back to the folder and open this file and add new code. So adding new line of code. Now remember that I have committed this file, and after commit then I have opened this file and added a new line. Okay, so if I go back here and type git status, so you see that nothing to commit, working tree clean. Save this file and come back again and type again the git status. So you see that this file is modified, right? Because we have just modified this file after the commit. Now you can also do is that you can see the changes using the Git Diff, but right now we are just focusing on the Git stash. Now you're in the middle of writing the code and suddenly you have been asked for an urgent task. So you need to create another branch, do some work, and continue your work from here. So here basically we have to use the git stash. So simply I will say git stash and press enter. So it says that saved working directory and index state work in progress on main and added a new stash demo file. This means that your file is now stashed. Okay. And if I go here and type git status, you will see that the working tree is clean now. Now, if you want to see the number of stashes, so you can do a multiple stash. So simply what you can do is that git stash space list. So it will provide a list of all the stashes. So I have created one for the demo and currently I have created one for this tutorial. So you can see that we have two stashes over there, right? Now what I will do is that create a branch. So git checkout dash b new dash branch. Now I'm switched to the new branch and here let's create a file in this particular branch. So simply right click and new file, new feature, and here I'll type something new feature. Save this file and come back here in our git bash and here just type git status and you see that this is a new file. Simply again we will do git add, then git commit dash m new feature or test completed. This was your urgent task which you have worked on the separate branch. You have added that file to the stage. Then you have committed this file. Now this file has been committed. Now we need to switch back to the main branch. So git, because we have to resume our work, right? So git checkout main. And now we are in the main and simply we can apply the latest stash without removing it, or we can apply or remove at the same time, right? So for example, git stash pop. So as soon as I use this command, so basically we can see this our modified file and here it says no changes added to the commit. Use git add or git commit dash a. Drop reference is this one. And if I type here git status, so now you can see this modified file, right, which we see previously. Now what we need to do is that we can simply open this file. We'll go back here, stash demo, right? And you can see that we have where we left. Now we are starting from there. So completed code, save this file and go back here again. Now git status. So this is a file, again git add, right? And we can commit the file. But before that, we need to understand a few more concepts. So basically what you can do is that we have a command called git stash apply. So basically you can apply the specific stash. So previously when I was showing you, if I scroll here, up. So just go here a bit where it was showing all the stashes. So just let me scroll a bit here. So you see that we have stashed this and this one. So if you want to apply any specific stash, so simply git stash apply, then you need to type this one. So stash at the rate 1 if you want this one. If you want this one, so stash at the rate curly braces, and inside that you have to give a number. And if you want to delete a specific stash, so simply git stash drop, git stash drop, and again stash at the rate, and whatever you want to delete you can delete. And if you want to delete all the stashes, so git stash clear. Okay, so if I go here, git stash clear, so everything is clear now. So if I type git stash list, you will see nothing over here because we have deleted all the stashes, right? So again, if I type git status, your file is still in the modified, so simply git add, then git commit -m, and you can commit your file, and your file is committed. So the whole concept of stash is that you was working and you're doing some script. In the middle you have some urgent tasks, you need to switch the task, but before that you can stash, means that save them temporarily, and then you can switch your branch, do your other stuff, come back and apply the stash or pop the stash, or if you want to delete the stash, whatever you want to do, you can do this and continue your work.